I am very excited to be here. We've had such an interesting session. And what's cool is that we've had all our speakers come online, but the trainer is with us here physically. So this is where we need to yank out our notebooks, our pens, and really listen to this session that is so relevant to what we are talking about. And it's about measurement and verification. We've talked about Renewable Project. We've talked about their implementation, but how do we prove those savings? And that is what this session shall be looking into. So let me introduce you to your speaker, who is here with us. And he is an actual icon, an actual legend in the energy space. He has a career that spans over 4 decades. I think we had one was 30 years, then we had about 3. Now we have a speaker with a career spanning over 4 decades, an energy expert with a background in electrical engineering. He also has amassed a wealth of experience from Kenya Pipeline. In fact, he led the team to China that designed the upgraded pipeline system that we are currently using. So we are dealing with an actual icon. And despite having such a decorated career, what's most relevant today is that he is a trainer at heart. He's trained both locally and internationally. And what's so cool is that last week, he was the first Kenyan to train the Certified Measurement and Verification Professional course last week, the first Kenyan to give it to the Sub-Saharan Africa CMVP course. So the content is still fresh and very relevant to today's topic. And what's so cool about this conference is that we do not have only one AEE CMVP certified trainer. We have 2. Shout out to Ben Mackenzie, who is also a CMVP trainer among us. So ladies and gentlemen, put your hands together for the one, the only engineer, J.O. Manyala. Louder as he gets to the stage today.
So thank you very much, Liz, for that generous, I think I dare say, over-generous introduction.
We've talked about the youth handling it, but I've forgotten something. The cool thing about this training is that there are goodies at the end of it. This is the only session where you're not going to get to just shake the hand of a speaker. At the front, after doing deliberations for hours and having proposals and no gifts, this is the session that does have a gift and the goodies at the end of it. So pay attention. We're going to have some quick fire questions at the end, and those will have 3 lucky winners to get some goodies. Thank you.
Thank you very much, Liz. First of all, let me thank the Secretariat for a very wonderful session that we have had since morning. We have had very experienced speakers from all over the world, as you've seen, giving us insights into various aspects of the renewable energy space. I know sometimes in the afternoon like this, the eyelids tend to get some extraordinary unique weight, and they respond very well to the gravity. So please, let's see if we can try and keep the buoyancy up so that they don't fall. A lot has been said about energy. A lot has been said about projects. We have had new words since yesterday about how projects are done. What do we do with these projects? How do we evaluate them? How do they become bankable? Etc., etc. Now, to be able to tackle that, there are certain things that we must do as energy professionals. And one of them is measurement and verification. Now, we will also, on top of that, look at aspects of measurement and verification that relate to the renewable energy space. Let us see what this will cover. I hope this works. Yes, it does work. Yeah. So we will very, very briefly cover some of the topics that you can see on the slide. We don't anticipate to make you M&V professionals in one afternoon. So if you don't get everything, don't worry. There will be opportunity later to talk to Karen and go on to some of these training programs that she has. Beautiful training programs. Karen is over there. That will turn you into a professional stepwise. So some aspects of the draft 2022 energy regulations that are currently somewhere just about to hit the space. Then we will look at what measurement and verification means. Some of the protocols, because we don't do M&V outside confines of certain regulations. So we'll also just briefly highlight some of them. We will also look at the fundamental principles that we apply in M&V, because like any other science or art, it has its own tenets, and we will look at that. The options that are normally applied when you are dealing with M&V, and why use M&V, by the way? That question we'll try and answer as we go along. Now, one of the key documents that you have in M&V is what is called an M&V plan, because it is out of that plan that the M&V process is premised. That plan details everything you do from the day you start your exercise to the day you conclude it. So that is our key document, and we look at some of the contents of an M&V plan. Not all the contents, because as probably I've realized now, projects come in different forms. They are of a different type. They have different objectives, and therefore the plans are different. But there are certain basic characteristics that run throughout all the M&V plans. So we look at some of them. And then how do you calculate savings? Because we have been talking about projects since morning. You do a project, it is supposed to give you certain impacts. How do you determine those impacts? That question is normally answered by this thing in the room called M&V. And finally, we will look at M&V from the perspective of the renewables, because that was the thrust of this particular workshop or conference. So, right off the Hoven, we have some presentation that was given early this week by APRA. For those of you who may not be familiar with APRA, APRA is our regulatory authority. In full, it means energy and anybody who can complete it for me? Yes, madam. Of Kenya, because there could be others elsewhere. Thank you very much. Give a big clap, you guys. Excellent. So early this week, in fact, on Monday to be specific, APRA gave a presentation to the Association of Energy Professionals of Eastern Africa, normally called APRA. Some people in this room are members of that organization, which is really a good thing. Now, they gave some highlights on what is currently happening with our regulations. The regulations are currently being revised, okay? And this journey to revise the regulations started in 2019, 2020. And as we sit here today, we are anticipating them to come out anytime, because they are currently with the Cabinet Secretary for gazettement, okay? So very soon we may see these new regulations being released for use in the country. So let us prepare to take advantage of some of the opportunities that will be offered by the new regulations. Now, what are some of the aspects of the new regulations? This is verbatim. I'm lifting directly from the presentation of APRA on Monday. Now, the first thing that will happen, especially for people who are operating in the energy space and who are operating in the area of measurement and verification, there will be a change in categories. Previously, we had only 2 categories of, say, auditors, and now, of course, we are going to have measurement and verification professionals. So 3 categories have now been proposed in those regulations. The first category is EMV. Now, EMV means an auditor who was initially in category A, but now they are being recategorized so that they can also do measurement and verification. Now, there is also auditor EA1 who can do a lot of audits in our facilities that are categorized as designated facilities, but do not have the M and V component of skills. Therefore, they cannot do measurement and verification, but they can do all the other energy audits. And then, of course, there's category AE2, which used to be category B in the initial regulations. These are people who are able to do, because initially we do 2 types of audits, investment grade and general audits. So this category AE2 are auditors who are able to do general audits. If I'm too fast, please stop me. Because when I get carried away, I have this tendency of speaking very fast. So please slow down. Now, bullet number 2 says the highest class, which is AEMV, will now be able to do measurement and verification. Now, this word ESCO has been with us since morning. We have heard of ESCOs, we have heard of projects, we have heard of bankability, and so on and so on. So as we go along, we will try and just give you a hint of what an ESCO is. Sorry, maybe I need to stand close to the computer, maybe too far. So I have already explained the categories, okay? What was initially subsisting in the country and what they will graduate to when the new regulations are implemented, okay? So we don't have to go there again. You have energy auditors or energy audit firms in this country. So they are categorized either A or B, and the new categorization now will be A, EMV, and EA1, EA2. And then for firms, there will be EF1 and ESCO and EF2, which I've explained. So what is an ESCO now? Because we have been talking the whole day about an ESCO. Is anybody brave enough to tell me what an ESCO is? It is on the board. So you don't have to worry, just read. Don't feel shy. In fact, I noticed that we have a lot of shy participants in this room. If you want to get into the energy space, you must be bold. Very, very bold, because you are going to deal with CEOs who will take you to task and ask you very tough questions about your promises. So start learning to be bold, outgoing. If people are wanted to do presentations in front, come in front and do the presentation, because it helps to sharpen your skills. Okay? So I want to see bold people, bold ladies and bold men. Okay? So ESCO is defined as a corporate entity that is engaged in undertaking the business of energy audits, development, design, financing. Financing was key. You remember when you talked to when Steve Fox gave his presentation, when Fitzwilliam gave his presentation, financing was a major component that you have to deal with in the energy space. And why does this arise? It arises because in many cases, we go and do audits in facilities. We give recommendations, and then these recommendations start gathering dust in the shells of the bosses, because they say, okay, your recommendations are very good, but we don't have the capacity or the internal resources to finance the project, or we are not even able to access bank loans to finance the project. So this idea of financing becomes a critical component of the activities of an ESCO. A good ESCO will give you a pipeline of financing models that you can use in case you have a bankable project, but you don't have internal funds or you're not able to borrow. Okay? Now, according to the presentation by APRA, these are some of the things that ESCOs will be able to do. They are entitled to undertake audits of designated facilities. And that word designated facilities is important because in Kenya here we categorize our energy consuming facilities at either low consumers, medium consumers, or high consumers. The designated facilities are generally the high and medium consumers. And currently our regulations say if you consume more than 180,000 kilowatt hours of energy in total, both thermal and electric, then you are entitled or required to do an energy audit, and we consider you as a designated facility. Okay? So, what else can they do? They can design, they can develop energy conservation projects, and this is so key, and this is where we need M&V. The compensation is directly linked to actual energy savings. So how do you determine those energy savings? And that is why you can't get rid of me from this place, because I will provide that platform for determining the savings. And I do it through what? M and V. M and V is the short form for measurement and verification. Are we together? Very good. So, dilemmas, problems and challenges or opportunities that we have with respect to M and V in Kenya at the moment. These capacity challenges to conduct M and V means that we do not have adequately trained resources or enough of them to do the amount of work that is available in this area. But we have also talked about financing of energy projects. Okay? But key is people to undertake M and V. So the young people in this house today, you are very lucky because this is going to open opportunities for you. M and V professionals are going to be required going forward. Jump onto this space and take advantage of the opportunities that will be there. Don't look at don't worry about the dilemmas and challenges. Let us look at the opportunities, and they're going to be there in large numbers. Not only within Kenya, but I think even within the surrounding countries. What is anticipated to be done in the country as per the APRA presentation is that they want to promote the establishment of ESCOs and super ESCOs. You remember we have already defined ESCOs as corporate something which is allowed to design, implement, finance, etc., etc. Now, there is also a higher level of an ESCO which is called a super ESCO. Currently, we are also struggling in the country to develop one super ESCO through our utility supplier. And the super ESCO now is supposed to deal with the smaller ESCOs and hold their hand and show them how to walk the ESCO journey. So this is the trend worldwide, and Kenya is catching up very, very quickly. Now, the other thing that the authority intends to do is to improve the quality of energy audits and adopt measurement and verification. So this is why I keep on emphasizing, please, the young engineers, opportunities are knocking here. Get into this space so that you become an M&V professional, because going forward, the space needs you. Okay? So, what is M&V? Now we go into the actual discussion. That was just a highlight to try and whet your appetite so that you can see how the scenario is evolving. You can see how the opportunities will come on board once these new regulations are promulgated. So now into the real meat that brought us here this afternoon. What is M&V? In M&V, you are thinking of certain things. You are thinking of planning. You are thinking of measuring. You are thinking of collecting and analyzing data. You are also thinking of verifying savings that you have achieved from the energy project that you are evaluating. And finally, of course, you must develop a report to give to the client or to give to the stakeholders, because sometimes when you do these projects, there are several stakeholders that are involved in a project. And this definition is taken from the International Performance Measurement and Verification Protocol, simply called IPMVP. So when you hear people talking about IPMVP, it is not something out of the ordinary. It simply means the International Performance Measurement and Verification Protocol. And this definition is according to the latest protocol, which was released this year sometime in March 2022, sorry. Of course, you'll find other definitions of measurement and verification, but we will see later on that there are many protocols being used in different parts of the world and in different countries, but the most frequently used protocol is the IPMVP protocol. And that is why I pulled out the definition from IPMVP 2022 version. Measurement is highly valued, and throughout the years, through the ages, there have been nice quotes about measurement. And one of the ones that we like referring to a lot, and I believe some of you probably have come in contact with this, is this quote by Lord Kelvin, who said that to measure is to know, and if you can't measure it, you cannot improve it, because you do not know where you are. Okay? You can only improve something when you know your reference point, and that reference point is created through measurement. So this is a popular quote that you'll meet when you get into the M&V space, because it has important implications on measurements. Another famous quote is by this lady called Grasshopper, who was a computer scientist in the US, and also a Navy admiral, that is like one of the bosses in the Navy. And she said a very fundamental thing, that one accurate measurement is worth 1,000 expert opinions, because every expert will have their opinion. Kelvin here will tell me something, somebody else will say, but this lady said, just give me one accurate measurement, and I can throw all the other expert opinions out of the window. Okay? So measurement is important. You can see that great luminaries have talked about measurement because of the value it has in our daily lives. So, fundamental principles, I had promised you we'll talk about fundamental principles. Although these principles are based on the IPMVP protocol. They cut across all the protocols because all the protocols aim to do the same thing: achieve credible and verifiable measurements. And therefore, these principles, they cut across all those protocols, standards, or guidelines that we will have a look at later on. So the first and most important fundamental principle of M&V is that it should be as accurate as you can get it, as accurate as the resources will allow. Because sometimes once you start doing M&V, you will also realize that if you increase the accuracy, the cost of measurement goes up. So there must be a balance between the cost of measurement and the accuracy that you aim to achieve. So within the resources available for you in doing your M&V, you try to get it as accurately as you can. That is the essence of that principle. The second principle is that when you do M&V, it should be complete. Complete means that you should not quickly rush through and down the line, 2 years, you realize that you left out a critical factor that impacts on your results. So you should carefully look at the project, carefully evaluate the project, and make sure that you have incorporated everything that is considered necessary to evaluate the project. The third principle is that your M&V should be conservative. You know, sometimes when we do the sales page and we want to convince somebody to give us work, we give very nice and enticing figures as to what we will achieve by implementing a particular project. Okay? And when the project is implemented, then you find it is not giving you the results that you are anticipating. Therefore, one of the cardinal principles of M&V is that you make it as conservative as possible, and if possible, be on the lower side, so that you over-deliver but under-promise. You know that phrase, eh? Because if you are on the other side and things go awry, then you will be in trouble with your stakeholders. Now, the other thing is that your M&V should be consistent. Consistent in that if I do M&V today on a particular project, I should do the same M&V 2 or 3 years down the line on the same project. I should not be changing course midway. Okay? So whatever I do must be consistent and it must be credible throughout. Also, it should be not only consistent in one particular project, but it should be consistent across your project portfolio. Whatever projects you're doing, the principles should be the same. Now, the M&V should also be relevant, because if Mike there at the back is producing bricks for buildings, and somebody else is producing jet engines, the kind of M&V that you'll do for the manufacturer of jet engines is not the same as the kind of M&V you'll do for somebody producing bricks for buildings. So that is the essence of that principle, that you do not bring on board things that are of no value to that particular project. And finally, M&V is supposed to be transparent, so that anybody else who comes on board to look at your report will arrive at the same conclusion. You must, within your M&V process, disclose everything that is relevant to that project, so that any other M&V professional will see the same thing. Not come and ask you, what did you do with this? You have some passwords hidden that nobody else can access. No, M&V is not supposed to be done like that. You must make sure that it is transparent. Now, I was told this is a training session. Anybody with a question up to this point? Anybody with a question up to this point? Or is the material too tough? Because M and V, sometimes people get lost, but I want us not to get lost. What I want us to do is to appreciate that there is something that we use, a tool that we use for evaluating the success or the failure of projects when we implement them. Yes, ma'am. Can somebody give her a microphone, please? We are doing this so that we go against that gravity thing. Huh?
Thank you. My name is Jili Mureri. I'm an electrical engineer and energy enthusiast, though I work as a safety and health officer. My question is based on some, let's say between 2019 and 2021, I worked with KTDA under the Energy Management Department. So we did a lot of general energy audits. And then most of the things we were doing, we were doing measurements by collecting. We also analyzed the data, and then we did cost. There's something to do with analysis, of course, savings analysis. Yes. So I'm trying to understand the difference between that general energy audit and the M&V based on the definition. Thank you.
Very good, Jean. That is a very good question. Excellent question. You will understand the difference once we go through all these things. So M&V has certain components. One of them may be or is usually data collection. But if you collect data and don't measure, you are not doing M&V. In fact, when you read this IPMVP, without measurement of one type or another, you are not doing M&V. Okay? So the M in M&V means measurement. You must take measurements. If you just collect data and you have not done any measurements, you are just groping in the dark. You do not know what you are doing. You remember Lord Kelvin? He said to measure is to know. Okay? And if you can't measure it, you can't improve it. Okay? So if you just do data collection and then analyze it without any measurements, you will be told you are doing something else which is not M&V. And that is allowed. There are some certain programs that allow you to do that. And you will hear of things like deemed savings, etc., etc. Okay? And deemed savings is not one of the ways to do M&V. So the bottom line to your question is, where you see M&V, there must be some measurement. Because I can collect data from manufacturers' manuals, isn't it? And do the analysis on my desktop. That is not M&V. Yes, you will have done something, you will have some ideas, but within the strict adherence requirements of M&V, that is not M&V. So you did something good. At least you have some data. Now, when you add onto it some measurements, you'll be on the right path to M&V. Okay? Not quite happy? Okay.
Sorry. What I was trying to say is in collection of data, actually we were doing measurements. Because let's say I was working on a boiler system.
Yes.
I had the flue gas analysis tool to take the measurements of the various gases there. The same if I'm working with the wood, I had the moisture content analyzer. Yeah, the same with the electrical one. So there was some measurements.
Good.
Yeah.
Very good.
Thank you.
Then, I didn't want to open the floor to discussions, but Kelvin here is an experienced data collector. So you might be able to throw in one or two things. Just 1 minute, Kelvin.
No, I just wanted to maybe put it in perspective, because what you did was an energy audit, right? So if you had gone ahead and implemented something, let's say if it was the boiler, and you did something to improve the efficiency of the boiler, then what you would do now to determine that efficiency improvement and report it is what would be MNV.
Excellent. Thank you very much, Kevin, for that clarification. So let us make some progress, otherwise we'll be here until tomorrow. So, in the IPMVP, there are certain approaches that are used for measurement and verification. And the IPMVP calls them options. Now, other protocols may call them other names, but since IPMVP is the most widely used protocol, we will look at some of the options that are available for doing M&V. Because of the nature of projects, because projects are not all the same, IPMVP provides a framework so that there is flexibility depending on the project that you're doing. So IPMVP has 4 options for analyzing projects. The first option is called option A, where you measure what are called key parameters. Previously, they used to call it key parameter, but now they call them key parameters in the revised version, because it has been realized that sometimes you have more than one parameter that is driving your energy consumption. Now, option A allows you to measure certain key parameters, but also estimate or stipulate. You will hear the word stipulate when you read literature. Stipulate means you can actually pick that data from sources other than actual measurement. For example, the most famous one that we give is a lighting retrofit. Say you wanted to retrofit the lighting in this room. You want to move from one inefficient lighting system to a more efficient lighting system. The key parameter that you may need to measure is the power draw or the demand of the lighting system before and after implementing the retrofit. But also for you to be able to get energy, the electrical engineer here will tell you, you must be able to multiply demand by time. You do not have to measure time. You can agree with the facility owner that our lights are normally on for just 6 hours in a day. 6 hours is not a measurement, it is an estimate, it is a stipulation, because you have picked it through means other than measurement. So that is a case where you do a project, you measure certain key things like the energy draw, but you can estimate or stipulate others like the time. Because for you to get energy consumption, you need both the demand and time. Non-electrical engineers, because the electrical engineers will be very, very comfortable with that. Okay? Now, the second option is option B in M&V. Now, this option forces you to measure all parameters because of certain reasons depending on the project. I saw Davis and Shutcliffe here, they deal with pumps a lot. And if you want to move from one standard pumping system, say, to a more efficient one, and you have installed, say, a frequency drive on the pump, for you to get the actual energy consumption after implementing that project, you can not only measure the power draw, because that power draw will be going up and down depending on the demand on the pump. So the time element becomes extremely important. So in that case, you must measure the power draw, you must measure the flow because the flow will determine the power draw, and then you must also measure the time for which the pump runs, isn't it? So you see a different scenario from just a normal lighting retrofit. Okay, here you have power demand, you have flow which drives the demand, and you have time because the pump may be running 20% daily at say 80% flow rate, or it may be running at 50% at say 30% flow rate, etc., etc. So here you must measure all parameters to be able to determine your energy savings. Are we clear about A and B first? Because those are the easier ones. Then there is option C, which sometimes in other literature you will find being termed whole facility approach or whole facility measurement. Now that is when you are not bothered about what is happening within a building or within a facility. You are only interested in how much energy do I pump in. Then I do many projects to improve that energy efficiency. Then I come and do another measurement to see what has happened with the facility. Okay, you are acting at the facility level. You are not looking at an individual energy efficiency performance intervention. Okay, what is normally called ECM, energy conservation measure, or energy efficiency measure. Okay, so there is that distinction. At the whole facility level, you are only interested in the power coming in at the input level. You are not looking at what is going on around everything, HVAC, lighting, whatever is being done, pumping, etc. So that is another very popular option, especially when you are looking at energy consumption at the global level. And then finally, we have what is called option D, which is calibrated simulation. This option, you may not come across it very frequently. I have done a lot of audits, but I have never used calibrated simulation because it is a situation where, say you have a new building and you want to determine the energy consumption of this building, whether it is performing better than the existing standard buildings, because you have done certain things in this building which you think will make it be more energy efficient. For M and V, there is something called baseline. We will just see a bit of it. So you must establish that baseline because it is your reference point from which you will measure your energy performance. But in a new building, you don't have that baseline. You have not collected any data. You have not done any, you have no bills, you have nothing, okay? So for you to be able to determine the performance of this building, then what you do is you simulate the energy consumption of this building using now the data you have going forward, because the building is now available, it is being used, and then you can now reflect back on what this building would have done without those interventions that you put. Slightly more complicated, not frequently used. I have never used it myself, but it is an option that is available and very heavily used in the West, especially when they do these so-called green buildings, which we are also doing in Kenya. They use this calibrated simulation. Okay, so I'm bringing this on board because there are options that you may come across in literature, and it is important that you have an idea of what they mean, because we said we are not going to be professionals or experts in one afternoon, but we should be able to understand when somebody talks about calibrated simulation. I know, oh, he may not initially have had data to reference his baseline, or he may have had data in the baseline, but that data is not good enough. But in the reporting period, when he's determining his performance, he has better data. So you can actually use this calibrated simulation to go back and determine how well the building is performing. So let's see what next we have. Sometimes it goes to sleep. Are we able? You can push it manually. Fails. Sometimes technology fails us. Okay. So you remember we asked a question: why use M and V? Okay. So calculation of energy savings for projects that have high uncertainty requires M and V because it offers you the principles which are accepted by all the stakeholders. Verification of installed performance against manufacturer's claims, because sometimes when you buy new technology, the manufacturer will tell you 1, 2, 3. Now you can only verify that when you use M and V. Without M and V, you will not be able to do it. Now, the other thing is M and V enables you to state a verified result, which can be stated with confidence and can prove return on investment. Now comes back to haunt us, that word bankable. Yeah? Investment. How do you verify? How do you determine that your investment has some returns? Now, the word confidence is also now appearing for the first time, because in measurement and verification, it is a requirement that when you give me a result, then you must state the confidence with which you are giving me that result, and you must also state the precision of that result. Let me give you an example. I tell you the consumption of a particular motor is, say, 300 kilowatt hours plus minus 3 kilowatt hours at 90% confidence level. That is a complete statement of a result. Without that complete statement, your result is of no value because people don't know. If you simply say, my result is, say, 300 kilowatt hours plus minus 3 kilowatt hours. I don't know the confidence you are attaching to that result. Is it at 50% confidence level? Is it at 90%? Is it at 20%? So a result that is stated through M and V measurement must have those two components. It must have confidence level. It must have precision level. Okay? Because if two people give me two results, one says, the measurement I've taken of this motor is 300 kilowatt hours plus minus 3 kilowatt hours at 95% confidence level. Somebody else says, the measurement I've taken is 300 kilowatt hours plus minus 3 kilowatt hours at 50% confidence level. Which result would you trust? 95% confidence level or 50% confidence level? 95. I would trust 50. Why not 50? Okay, you are right, because when I tell you that my result is at 95% confidence level, what it means is that if I take measurements of this motor several times, then I am 95% sure that that result will lie between 297 kilowatt hours and 303 kilowatt hours. But if I tell you 50%, then I'm only 50% sure that the result will lie between 297 and 303. Okay? So confidence level is so important in measurement and verification. You must state it. And then precision. And of course, when you do advanced courses, you will be taken through how to determine that precision, etc., etc. Okay? So if you don't quite get it, don't worry, use layman's term. If I tell you I'm 95% confidence about a result, then you know it will lie within this range 95% of the time. If I tell you 50% of the time, you know it is only 50% of the time that it will lie within a particular range. Okay. Demonstrate performance where a financial incentive or penalty is involved. Yes. If you are in the M&V space, it is not smiling all the way to the bank all the time. Because sometimes if you give stakeholders the wrong results and you had promised heaven, but you are now showing them hell, there are certain penalties that you may incur. Okay? Because normally, as the ESCO people will tell you, you do a contract or an energy performance contract when you do this measurement and verification. And that contract you have undertaken or you have committed yourself that this project will achieve certain savings. If it doesn't achieve those savings, what do? Sometimes you find penalty clauses incorporated in the contracts. Okay? So be careful what you are claiming. And now we go back to our 6 principles. Remember, we said we must be conservative so that if things don't quite work, you had already covered yourself by stating something that is not overboard. Are we together? Good. So, building of business cases, bankability. Again, in different ways. A bankable project is we have built a case to promote a particular business concept or business venture using proper metrics. Those metrics are generated through M&V. And therefore, the final thing, which is really what I want you to take away from this slide, is that in a sense, M&V or measurement and verification is intended to answer a very simple question. How can I be sure I'm really saving money? This man has come and promised me, or this lady has come and promised me. How can I be sure that what they promised is happening? The only way you can be sure is through M&V. And that is why M&V becomes so important. Good, let's make some progress. Unless Secretariat, you want us to take a break? You're okay? All is well. Okay, we continue. So, M&V also provides a uniform basis for evaluating energy or demand or water savings because everybody will be talking the same language. Everybody will be using the same processes to arrive at the savings. So there is no ambiguity, there is no conflict, there is no push and pull because we are all using the same basic principles to evaluate the projects. And therefore, it mitigates against conflict, against disagreements when something goes wrong in the project. Because if it goes wrong, people understand that it went wrong because of 1, 2, 3, because we have used the same principles, all of us. Now, that second bullet point is important because if you have an energy performance contract, you are an ESCO, then your payments will be pegged probably on the savings that you make through that project. And therefore, you need that for everybody to understand that you are using the same principles. And therefore, if there are any issues, they can be addressed using those principles. So without M&V, no confidence in energy efficiency projects. Because one of the things that you learn when you jump into this space is that there is no meter for savings. You cannot put a meter and say, now I am saving energy, isn't it? For you to be able to determine savings, you must measure before consumption and after consumption, and in between, you must also make certain adjustments to get to your final result. Okay? So there is no meter that will come and sit there and give Ben here some savings. Okay? So you need M&V to be able to arrive at that saving. That is what we are going to see in the subsequent slides. Okay, I talked about the M&V plan, sorry. See, these are some of the things that you need to include in an M&V plan. Okay. They are in the slides. You can read them later on. Because of the sake of time, we'll not go through all of them. But the key thing is that plan must indicate the kind of approach that is intended and the M&V options. Remember, I gave you the 4 options. So for this particular project, which option are you going to use? That must be stated in the plan so that people are aware. The other thing that is important is the savings calculation method, and we'll see 1 or 2 later on, and the energy cost rates to be used. I had a very interesting experience where we did a project, M&V, done well, but during the course of that project, fuel prices went up, energy costs went up. So the project owner came back screaming and saying, you people promised me that I was going to save money through this project. And now I am paying more than I used to pay before you appeared on the scene. So what went wrong? You people cheated me. Because it was a lady. She had not taken into account the fact that the energy prices had changed. Because when you do your measurements, you actually find that there are savings. But these savings now are being determined at a different pricing level. So normally in M&V, one of the things that you do is you fix the rates before the implementation of the project and after the implementation of the project so that you can use the same rate. Otherwise, if the rates change and people don't understand, you will be hauled to jail, you will sleep in a police cell because you lied. Eh? False what? What do they call it? Getting false pretenses. You see, these guys are clever here. They know these things. So it is important that you do that. So all these things must be detailed in your M&V plan, and even assumptions that you're going to make. Okay? Because, for example, when we do audits, we make certain assumptions in arriving at results. One of them that we normally make is that for every kilowatt hour of electricity that you use in this country, you generate 0.33 kilograms of CO2 emissions, isn't it? That is an assumption. So people must understand upfront that at the end of the day, when I want to determine your CO2 emissions or CO2 savings or avoided emissions, then there is a conversion factor that I use, and that conversion factor must be stated upfront in the M&V plan so that everybody knows what is happening in the process. Somebody else will not come with their own figures. And some of these conversion factors, of course, depend on the country where you are. If you are in Kenya, where our energy mix is fairly clean, our conversion factor is very low, 0.33 kilograms. I've seen some countries where they go up to 0.65, okay? Depending on their energy mix. If they're using coal to produce electricity, then the conversion factor is much higher, okay? So if somebody came from some island and then he saw our conversion factor of 0.33, then he starts screaming. We'll tell him, no, this is what we do because our energy mix is clean. So if they're used to 0.7 and they say we have done wrong calculations, we refer them to our conversion factor. And by the way, these conversion factors are standard for the country. So every energy auditor in the country will be using the same figure. Okay? We have looked at that. You can read that later on. Now, this equation, you can see we have put it in red. Normally, when you see red, what does it mean? Danger. But in this case, it is not danger. It is just for emphasis. Because this is an equation that you will continue meeting every time you talk about measurement and verification, you talk about energy savings or avoided energy use, you will be coming across this equation. Okay? And we have said it is general because you will see different renditions or different variations of the same thing. That your energy savings or avoided energy use, it can also come in those terms, is always equal to the baseline energy consumption minus the reporting period energy consumption plus minus adjustments. Now, it may look very simple, it may look very innocent, but there is a lot that goes behind this simple equation because it is the foundation of determining energy savings in M&V projects. Just an example of how we do some of these things. When you do an energy efficiency project, there are normally 3 distinct phases of the project. There is the period that we call the baseline period. That is the period just before you do the project. There is the period when you are installing the project, you are tuning it, you are doing everything else. And then there is the reporting period, or sometimes we call it the performance period, or some people call it the measurement period. Okay? Now, these 3 distinct phases have their own unique characteristics. In the baseline period, what you are doing is you are establishing the energy profile of this facility you are dealing with. Like in her case, she was at KTDA, they were collecting data of boilers, energy consumption, water consumption, etc., etc. So once you collect that data and analyze it and come up with a profile of your facility, if you implement any interventions or any measures, you can use that baseline to see or determine how much savings you've achieved through that intervention. But the challenge is that it is not just a direct comparison. Okay? You can't say, okay, last year before I did this project, I was consuming 30,000 kilowatt hours. This year, I have gone back and taken measurements, and I find I am consuming 25,000 kilowatt hours. So my saving is 30 minus 25, isn't it? That is how you would argue, generally, before you do M&V. That is not the correct way to do it. Why is it not the correct way? Because your interest as an M&V expert is to determine the impact of the intervention itself. So you must be sure, or you must ensure that you separate out any other impacts on the facility. A good example is a building, say somewhere in Canada. It goes through cyclic seasons. You have winter, you have summer, you have autumn, you have spring, etc. And the energy consumption of this building will be different depending on the season during which you measure it. Okay? Because when it is cold, you are cooling. When it is summer, it is very hot. In July, August, you are cooling. Okay? So the energy consumption is influenced by the environment or the weather around the building. Let us assume that in this building now, you put in a new chiller to improve the performance of the HVAC system. Okay? Your interest as the implementer or the facility owner is to determine the impact of this chiller. You are not interested in what the weather is doing, because if you don't separate out what the weather is doing, then you'll not be able to see the impact of the chiller. Okay? And that is the sense of this thing here. So, to cut a long story short, what we normally do as energy professionals or M&V professionals is to, first of all, take the baseline data, analyze it against the energy driver, if it was weather, you're using cooling degree days or heating degree days or whatever, or a combination of both, then we do an analysis, generally called a regression analysis, because what happens in a lot of these energy systems is that you will find that there is a linear relationship between the energy consumption and the energy driver. Okay? So if it is during summer in a building, you'll find that there's something called cooling degree days, which will be driving the energy consumption in the building. And when you relate the cooling degree days to the energy consumption, normally you'll find it is a linear relationship. Now you can then now use that linear relationship as a model for the building. Are we okay or are we lost? I'm seeing some blank faces. I don't want people remaining behind. Do you agree that we can relate energy consumption to the energy driver? In this case, I chose cooling degree days because we are going to cool this building in summer. Okay? When you draw a graph of energy consumption on the vertical axis and cooling degree days on the x-axis, you will get a linear relationship. So that linear relationship is the model of that building in terms of energy consumption. So going forward, if you now do something, you can now use that model to try and predict what will happen to this building. Okay? So that is the blue line that you are seeing in this diagram. The blue line is the actual energy consumption of the building. The red line in the baseline period is the model. It is not the actual consumption, but it is the model of that consumption. So I can use that model to substitute for the actual consumption, isn't it? Because as you can see, they nearly hug one another. So the model is a very good representation of what is happening. Now, I do now a retrofit. I do a HVAC in the building. And then I want to find out the impact of this HVAC. I can then use my model with the environmental conditions or the weather to predict what this building would have done if I had not done the intervention or ECM. Because the building is still there. Whether you change the HVAC or not, the building will still be consuming energy. So using my model, I can say, let me try and predict what this building would have done if I had not improved the HVAC system. Now, when we do that, you now get something which is called an adjusted baseline. Now, that adjusted baseline can be used now to determine your energy savings. So what are the energy savings? We now go back to my red formula. Savings is equal to baseline energy consumption minus reporting period plus minus adjustments. I have incorporated my adjustments through the weather so that I compare what the building would have consumed without this intervention against what the building is actually consuming now with the intervention. That is the only way I am able to separate out the impact of the weather. Are we together? Because if I don't, the weather will still be impacting on my building and the intervention also. So I have no means of knowing who is doing what for me. Is it the weather saving energy for me, or is it the intervention? So I must be able to get rid of the impact of the weather and now specifically focus on what this intervention is doing. Together? I think we need a break. Lynette, we must stretch and write those C's and D's and Y's. Otherwise, people will fall asleep.
We can stretch. Please stand up. As you can see, I'm already relaxing into the evening. So those who are late, they don't know where we are going this evening. You'll be left in suspense. unless you follow us. But we can stretch. I think Carol's stretch yesterday was great. And we have a great word to stretch to. Savings. So, Hans Akimbo, you ready? Okay, let's start with the S. Make it count. Are you that stiff? No, make it count. We are going to go somewhere where we'll dance. For those who are there and they know where we are going, we'll be going to dance and we need to practice. Cindy, okay, give me an S. A small A. Where is the tail? Ensure there is a tail there. Then the V. Online team, please join us as we do this. A small I, and I need the dots. So figure out how you're doing the dot. I like what I'm seeing. Okay, small I, and then hey, good students. Small N. Yes. Then the G. This is where the magic is because it has a tail. So I need to see the tail. So G. You have to have the tail. Okay, and then an S again. The dancing skills. Excellent.
Excellent.
Back to you, engineer.
Thank you, Lynette, for that. Yeah, when we need that kind of thing, we get Lynette to do it. So let me just point here. You remember I said in this diagram, the blue line is the normal energy consumption of the building, okay? Ordinarily. Now, we have created a model of this energy consumption. Remember, it is a model, it is not the actual consumption. The actual consumption is this blue line here, okay? So, assume that we have not done anything on this building. Then we will get this in the reporting period. Because what we have taken is we have taken our model here and used the data during this period to generate this line here without doing anything. But because we have now done something in the building, the energy consumption has gone down from up there. We now have this one here. So the difference between what would have happened without the intervention and the actual consumption during the reporting period is our savings, or sometimes you will find it called avoided energy use. Okay? Now you will see different renditions of this diagram here, but I like using this one because it explains all the key parameters here. You have the actual consumption, then you have your model, the baseline model, which is here. Then you use this baseline model with your data here to generate the adjusted baseline. And the difference between this actual consumption and the adjusted baseline is your energy savings. This principle must sink because it is the key driver of M and V. Anybody challenged in that area? I don't want to say confused. Anybody challenged in that area? Nobody. Good students, I'm happy. So, let's see if you can make a few more slides. Okay, this is a hypothetical factory, okay? That now wraps up all these principles that we have been talking about. In this factory, you can see many things going on, not too many, but quite something. We have the physical boundary that surrounds this factory. We are producing certain things that we have called finished goods. They could be shoes, they could be curtains, they could be anything. But for us to produce those finished goods, we have to get raw materials into the system, isn't it? And together with the raw materials, we need energy. And in this particular case, we have two sources of energy. We have natural gas and we have electricity. The natural gas could be used for boilers, it could be used for heating of the building, it could be used for anything. Then there are certain things that impact on the energy that goes into this factory. Apart from processing the raw materials, we have the weather around. The weather impacts on the factory. There is also production quantity. How much we produce will determine how much we consume. If we produce little, we consume little. If we produce more, we consume more. And also what is important is the product mix. Because sometimes you have a factory and they are running only to one line to produce a particular type of paint. Sometimes they are running 3 or 4 lines to produce 3 different types of paints. So the product mix is important. And therefore, these factors that you see up there with inside that blue glow are the relevant variables. Remember I told you about the relevant things. You must use the relevant factors to characterize your energy profile. So if you're using producing bricks, this would not be relevant for you. The weather would not be relevant for you. Okay? The product mix may be relevant, production quantity may be relevant. Okay? So always make sure that you choose your relevant variables so that you can characterize the energy profile of the facility. Okay? So you remember our model in the baseline? There are certain ways in which the model is derived. And the first important thing is to identify the key energy drivers. What are the things driving the energy consumption? Is it the product mix? Or do we only have one product? Then you establish the baseline data set. You have your production values, you have your product mix, you have your weather, whatever is driving energy consumption. Then you have measurements of the energy that is being consumed. Then you develop your linear regression model, because it is the linear regression model that is the profile giving you the relationship between energy consumption in the facility and the energy drivers or the variables. Then you review the fitness of the model. Now here, you will have to learn a bit of mathematics, a bit of statistics, because not every model is appropriate to characterize the energy consumption of a facility. For those of you who are familiar with scatter plots, you can have a regression model in which the data points are scattered all over the place, okay? Then that model may not be a very good representation of the energy consumption. You may have a model in which the energy, the scatter plots are very, very closely hugging the regression line. So that model may be probably better than the other one. So there are ways of determining whether your model is really giving you the correct picture between the energy consumption and the energy driver. And there are metrics for determining that. For some of you who have already done some audits, you'll remember your R squared. And in many cases, you're told an R squared value greater than 0.75 is an indication of a good model fit, isn't it? I was waiting to hear yes or no. I'm not, people in the secretariat don't want you to answer because they have done this thing all over many times. But R squared alone may not be the only metric you need to characterize your model. There may be something that is called mean bias error. That is also one metric. There may be also something called CVRMSE, or the coefficient of variation, or the root mean square error. Those are factors that you will use to determine how well your model is predicting the energy consumption. Okay? So these are things that you can go and read about. We will not deal with them here. So the other thing that is important is you estimate the uncertainty of project savings. Remember I told you, if you give me just a statement that my consumption is 300 kilowatt hours plus minus 3, without any confidence level statement, without any further information about precision, then your result is out of the window because it does not tell me anything. So uncertainty is important so that people know that with this statement of measurements, I am 95% sure, or I am 65% sure, or I am 99% sure. So that uncertainty statement is important for people to trust your statement. Deliver model to participant, etc., etc. There is also the issue of dealing with missing data. That one will not cover here, but there are ways of cleaning up your data using certain procedures. If, for example, you go to a facility and you want to do this analysis like she did and she finds certain data is not available. For example, the frequent one is bills are missing. You find they give you bills, they come to July, they don't have a bill for July. How do you deal with that? Okay, M&V has procedures for dealing with that kind of situation. And finally, you review the model, and if it is okay, it is approved by everybody, then it can be used for your M&V plan. Because even this model must be captured in that M&V plan. Remember that I told you one of the most important documents is the M&V plan. So the model that you're going to use must be captured in the M&V plan. Okay, we talked about protocols. Let me see. We have a number of protocols that people use out there for M&V. ISO 50015 is one that is accepted worldwide. It will be used by many people. It has its own benefits. It may have certain limitations. If you go to North America, or the US specifically, for federal energy management projects, they will be using this FEMP guideline. I think the current version is version 4.0. ASHRAE is also very important, especially for buildings. And ASHRAE is a guideline that is used also a lot in the US because it has certain characteristics which are different from ISO or the next one, which is IPMVP. The Australians have one they call the best practice guide, which is used in Australasia, that is New Zealand, Australia, etc., etc. Why you get so many guidelines is that all these regions of the world have their own unique characteristics. And therefore, as much as the guidelines have basic principles which are common throughout all of them, there are certain unique things in these various parts of the world which are incorporated in their guidelines. SANS 50010 used in South Africa a lot, and for them it is even mandatory because they have certain incentives that are computed in terms of taxes, in terms of demand side management, etc., etc. So they use SANS 50010. All these guidelines have their basis on IPMVP. You will find they talk the same language, but are tailored towards different regions of the world. And of course, now in Kenya, we have our KS 50015, which is our national standard for doing M&V. Okay, so if you want to do M&V in this country, you can also refer to KS 50015. But as I said at the beginning, the protocol that is most widely used, whether you go to Mongolia or you go to Australia or you go to China, is IPMVP, International Performance Measurement and Verification Protocol. That is the one that you will hear a lot of people talking about. Okay? And in some countries, you'll find them using both or several of them, depending on what they're looking at. Because certain projects will demand use 1, 2, 3. Okay? So there are these options that are being used very, very widely, depending on which part of the world you come from. Okay? Now, a bit of renewables. We said we are going to say 1 or 2 things about renewables, because you have now to reverse your thinking, because in energy efficiency projects, we do an intervention to improve the efficiency of the system and bring down energy consumption. That is not the driving principle of renewable energy interventions, because in renewable energy interventions, in most cases, if we talk about solar PV, we are actually generating energy, isn't it, to take care of a certain part of the load of the system. So the approach for doing M&V for renewables is slightly different, using the same foundation, but slightly different from the normal energy efficiency projects. So that is the key thing that I want you to carry away. So in most cases, for doing renewables, there is this source document called IPMVP Application Guide for Renewables. It's a very good document. It is available freely on the website of EVO. Just log in there. Maybe they'll want you to register and open an account. Then you can download it, because it is very, very good for doing measurements on renewable projects. The other thing is a lot of the M&V, a lot of the renewable projects, especially when you're talking about solar PV, for those of you who are in that area, you know that the payment period is slightly longer, okay, than, say, a standard thing. If I do a lighting retrofit, before and after, I get my results immediately, isn't it? Maybe within a framework of 2-3 months, I know how the system is performing. I do an solar PV project, I'm thinking of 4 years plus, isn't it? 4, 5, 6 years. Okay, so they are slightly longer term projects, and that you must take into account when you are developing your measurement and verification system, so that the cost factor is built into the M&V process. So we have talked about that for M&V in RE projects. RE, of course, means renewable projects. You must understand the nature of the investment because of the term of the project. It is slightly longer generally. And then you have to be able to determine how savings will be assessed. Are you looking at savings in terms of the reduction in your KPLC bills? Are you looking at savings in terms of the environmental impact that this intervention will have? What is your target? So that becomes important when you're dealing with renewable energy projects. There's the question of risks, which I've simply touched on briefly, but it is very, very well dealt with in this guide, because sometimes you do a project and the project does not yield the results that you had anticipated. Not because the project is not properly done, but sometimes the risks arise out of the energy resource you're using. For example, if you are going to Again, we come back to solar PV. And then all of a sudden, you have several months of cold weather, cloud cover, and you're not generating the kind of savings you are expecting. Those who live in Nairobi know that September was unusually cold, because normally by August, it starts warming up. But then it became so cold, cloud cover. And if you had a solar PV project, you will not be getting the same kind of savings that you had anticipated. So that kind of scenario must be factored into your measurement and verification process. Otherwise, you will get wrong results. Power purchase agreements. This I think is common in this country. We all know about them. And in this particular case, they are normally standard prices that are paid and agreed upfront between the stakeholder or the client receiving that service and the person providing the service. And normally it is designated in terms of a particular rate per kilowatt hour. And that is fixed maybe throughout the term of the project. So you must be aware of that when you are in that area. That one we have said, renewable energy sources, they deliver instead of conserve. What else is there? Measuring resource. Very important. Yeah, this is a good example of what I was trying to explain on the regression analysis. You can see that for this particular project, it was a solar PV project, and the resource that was driving the performance of the project was the radiation that is incident in this particular area in terms of watt hours per square meter. And then you are looking at the output of the system in terms of AC energy on a daily basis. And you can see that in this regression line, this project was very well modeled, and therefore the generation of the system is fairly projected using the regression line. You can see that many of the points that were measured really lie either on the regression line or very close to it. But assume that something didn't go quite right, and therefore there was some unusual event where you had a lot of cloud cover. You would not have a straight line like this, and therefore you must take that into account in the adjustments. So we come to the end of that short presentation. I want to reemphasize the thrust of this was simply to give you an overall picture so that you are aware of this thing called M&V, that it is the tool that you use for characterizing the performance of your energy efficiency projects, whether they are attaining the intention or whether they are falling below what was expected. It is the only way that you can use to evaluate energy savings. So on that note, I want to rest my case and hand it back to Liz.
Thank you so much, Engineer. Ladies and gentlemen, we had promised a value-adding session, and that is exactly what we've gotten today. Those of us who know Engineer, we fondly call him Engineer. I'm not even saying Engineer Manyala. That is how much we get to learn from him. I had promised goodies. I saw pens were moving, notepads were being filled. This is your time to shine. Engineer had also offered Q&A session. So this is your time. If you have a question, feel free to ask now before we get into the goodies session. Where I just have 3 fire questions for you. And then whoever answers them first gets goodies. So is there anyone who has a question for Engineer before we allow him to sit? Online team? co-absorb. That's how much. Do you have a question? You have a question at the back. Okay.
Thank you very much. Mine is not a question really, but just a comment from you. I believe I'm one of the young people who should look into opportunities you have elaborated very well in terms of MNV. From its definition, there is an element of bringing an NMV, a professional, during design. But my understanding, as you have elaborated continuously up to the end, there is always an element of saving, which is money. So my question is energy audit as a process which should be there in the entire life of the project? I'm just asking because, for example, the lady talked about the factory. So is it something which should be done annually, compared continuously to the life of the factory? Or is something which can be done like in 2 years, then you stop? Are there regulation which direct like this must be done annually for the general saving of energy? Thank you.
Thank you very much for that question. A very good question. And I want to refer you to our current regulations. I did indicate that we have existing energy management regulations called Energy Management Regulations 2012. Within the provisions of those regulations, currently, if you consume more than 180,000 kilowatt hours of energy annually, you are required to do an energy audit once every 3 years. Okay, so that is in law. But there are people who want to do audits every year because they have seen the benefits. The law does not prevent you. The only thing it says that if you consume so much, you must do an audit every 3 years. But once you do an audit, the audit will give you certain recommendations to implement to improve your energy performance. And the regulator expects that every year you will write what is called an implementation report. Okay? This report will tell the regulator that I undertook within these 3 years to do 1, 2, 3. So year 1, I did 1. Year 2, I did 2. Year 3, I did 3. Or I was not able to do anything because of X, Y, Z. Okay? So there is some element of monitoring in terms of the requirement to submit an energy implementation report according to the plan that you have submitted to the regulator on the basis of the recommendations. But some good news on the horizon. Within the framework of the revised regulations, now you will be expected to carry out an energy audit once every 4 years. So there is one more extra year that has been added in the requirements. I hope that answers your question. Thank you. They are a very experienced M&V professionals here. In fact, Liz had gone ahead of the cut because I wanted to let you know that I'm not the only M&V, CMVP trainer in Africa. I'm in sub-Saharan Africa. There are actually 5 of us. And this audience is very lucky because you have 2 of them in the house. Okay? Engineer McBen is one of the CMVP trainers. We train in the region in the sub-Saharan Africa. And we train on behalf of AEE, but through an institution called the Institute of Energy Professionals Africa, based in South Africa. Okay, they hold the training. What do you call that thing? something there. So they hold it and we train on through them on behalf of AEE. So I think it is important to recognize that I'm not the only person who can talk about M&V in the house. We have a guru there. He sat there very quietly, not speaking, but he's a walking dictionary. So talk to him. So there was a question at the back. Oh, sorry.
Okay. Thank you once again for this opportunity. Engineer Manyala, I want to say thank you so much. You have enlightened me. Actually, the one thing that motivated me to attend this conference is because I wanted to do one of those either energy audit or energy management to undergo that certification program. I contacted CAM. Actually, that is where the Eenovators either got my contact from. And then I saw the World Energy Day. I decided, I think this is the place to go so that I can get the enlightenment. And I'm saying thank you so much because I know I'm the right space. Now I'm thinking of not even only doing the energy audit, maybe to have more enlightenment to do M&V. Thank you so much.
Thank you very much. In fact, I want to refer you immediately directly to Karen. She's there. She will tell you everything about energy management training in this region of the world. Okay? So get her contacts. There are so many courses running at the up to the end of the year, especially CEM. And we have some trainers in CEM who are sitting in this house quietly.
Thank you, Engineer, for the good insights from your presentation. I'm not an engineer, but I might have some comments on the same, but I would maybe, I found there is some correlation between an MAV professional and maybe more or less of a QC, because you're doing some audits at the same time trying to save. At the same time, you're also trying to plan on the best options and ensure that you save as much as you can. And at the same time, using maybe the available resources that you have to be able to achieve whatever you want. So I was trying to come to the point. Is it more of a QC, like a quality control, or just a normal auditor?
Thank you very much for that question. In fact, within M&V, there is a quality control bit. There's a section of one of the things that you must do as an M&V professional, because I told you that your results must be verifiable. They must be accurate. They must be transparent. So there is a component of Q&C that is required when you do the M&V report. When you do the M&V report, it refers back to the M&V plan within which that quality control component is embedded. Okay, so there is some quality control within M&V, and sometimes they use the same data. For example, your QC charts. You also have control charts in M&V, because when you are in a factory situation, you have these technicians or artisans who are very busy people. They are attending to breakdowns and so on. So they don't want these elaborate things about this regression diagrams and so on. You simply draw control charts for them and you tell them, okay, if this machine is consuming up there, you know something is wrong. Go and check it, isn't it? A very simple control chart, but which is applicable in M&V, also in QC. Yes,
okay, thank you, Engineer, for that presentation. It's very enlightening. So my question is, you know, there are many companies now, of course, using hybrid energy, complementing their energy with the power, like, for example, the solar energy. And within the updated regulations, is it where we have, or rather, are they now allowing selling of excessive power back to the grid within that framework?
Yes, that relates to a different sphere of operations. There is something called feed-in tariff. Okay, it has not been quite implemented because the legal framework has not been finalized. I'm not the authority to speak on behalf of whoever is doing it, but the whole idea is that if I have my small rooftop PV source and I don't utilize all that energy, then the natural thing is to feed that into the grid and get either some what do you call it? Sometimes I forget these words. You get a net. You net it off what you consume. This happens in other developed economies, okay? And that is why you find that there's a lot of renewable energy being installed by private entities because they have that netting between what you consume and what you generate. If you give back to the grid, they will net off. But here we still have some issues with the legal framework. It has not been finalized, and therefore that principle is not currently being applied. Okay? But there are people who are more qualified to speak in that area. I'm just giving you the picture. Don't quote me.
Okay, thank you so much. I think you're looking for net metering.
Net metering, yes, net metering. Any other questions? We don't want you to leave here with doubts.
Okay.
I think people are tired, so
it is absorbing all that.
Those who came early, you see Lynette because she has something for you, but those who came late, you do not know what Lynette has for you.
Thank you so much, Engineer, for that session. A round of applause to Engineer Manyala.